everyone. Thank you very much for coming along. So yeah, I'd like to speak a little bit about how at Motorway we've been shifting gears, how we've been moving from a system that's got events to a system that we want to call a bit more event-driven. Firstly, a little bit about who am I. So I'm a principal engineer at Motorway. So we're an online used car marketplace based in the UK. I'm an AWS community builder, also in the serverless world. So I speak a lot about, or try and blog a lot about what you can do in the serverless ways on AWS. I've been building on AWS for 10, 11, 12 years now, I think. Started clicking around the console all the way through to building some, I guess, globally available systems on there. And specifically some more event-driven serverless things on AWS for around 6 or 7 years now. So for the next half hour or so, a little bit about what Motorway is, where we started, what we do, and why we do it the way that we do it. A bit about what I mean by a system with events versus a system that's becoming more event-driven. How we've made some changes to become event-driven, some of the benefits that we've got off the back of that, how we're able to move faster, more stable, scale better as a business in a cost-efficient way. And then finally, a little bit what's next, what we're currently doing, what we're doing in the next really, really near future. Actually, we started some of it on how to make sure we can continue to scale this event-driven system in a really, really safe way. Maybe first, actually, a show of hands. Was anyone at AWS EDA Day in London a couple of months ago? No one. Perfect. So some of these slides, are an improved version of what I presented there. So some of them I touched on a little bit there. About half of them are new, and some of them have changed. So it's a little bit more tech heavy than what I presented there a couple of months ago. But there is an alternate version of this presentation on the internet. But hopefully some of it's changed for the better. So Motorway, we're the UK's fastest growing used car marketplace. Sales agreed on our platform every 3 minutes, and we've helped over 500,000 people sell their car the Motorway way. Really cool catchphrase, sell your car the Motorway way. Not the first time you've heard it tonight, might be the last though. But in 2023, we actually moved over £2.5 billion worth of cars through our platform, through our system. So we're always innovating and building new things to help our dealer partners and our customers on the platform sell their cars an easier way to get the best price they can. So we're moving quite a large amount of value of the cars through there. We're around 5 or 6 years old. We actually started on Heroku. Anyone used Heroku before? Quite a few people. Cool. So Heroku helped us get going really, really quickly, validate the business assumption, get the company growing quickly and fast. At some point, we reached a limit of Heroku, wasn't working quite well enough for us, so we moved everything onto Elastic Beanstalk. Who's used Elastic Beanstalk before? Yeah, a couple people again. Interesting. Okay, cool. So Elastic Beanstalk didn't work super well for us either. So we very quickly tried to move off of that and on to Fargate. Supplementing this everywhere, we've got a large use of Postgres and Redis and RabbitMQ. Again, RabbitMQ, a really, really nice, it's an open source messaging system. It's a bus, router, pub, sub, queues, notifications, all the nice asynchronous things that you get. So we did make heavy use of that for a while. A typical system on Motorway, can people see this okay? Is it, yeah, cool? If you can't, just shout and I'll explain with words and move closer. We may have had a typical system like this. We've got a user who wants to profile a car. Before you sell your car, we want to take pictures of it, understand a bit about it, get the mileage, the service history, things like that to build a profile of it. We might store that in our database. And then over time, we might want to let people start searching for things. So maybe we want to let people see how often a dealer may have bought a car like this recently, how much cars like this have sold for recently, or let our dealer partners see how much similar cars have sold for recently. So we start to add a few more Fargate things into play. And we've got our dealer database, we've got a profiler database, we've got a search service in the middle going on here. So we're starting to synchronously join quite a few systems together. And over time, we started to see that synchronously making all of these requests wasn't always the most optimal performant thing that we could do. So we started introducing things like RabbitMQ. So we're introducing events at this point. But because we don't don't treat these events as first-class citizens on the platform. We're not strictly an event-driven system. They are there, but they're not forming the core of what we do. We find ourselves in situations where the events may not always reach the destination. They might hit a dead letter queue. We might have a failure on the network. They might not get processed successfully. And when that happens with events, you're losing state across your platform, and you need to make sure you can reliably recover from this. In an event-driven system, we would really consider these failure states and how we can recover from them. But with some of our systems, we find that we wouldn't always do that. So we'd find ourselves building systems like a resync service that every day, every hour or so, would copy data from one database and write it into another one, short-circuiting that asynchronous process in the middle and sort of just catching up and rebuilding itself as time goes by. So it's events without trust or purpose. Some of them, we may find that we've got accidental events. They're there, but we don't really know what they're there for, but we're using them in some places. Sometimes we might be publishing what I would call schema changes. So we want to make sure that we're publishing facts or events of purpose and what they're actually trying to explain that's changed in the system, rather than publishing an event that says this database column has changed from this value to this value. We're leaking out our schemas and sharing that across the platform, something that we want to avoid. A lack of dead letter queue or a lack of monitoring around dead letter queues, we don't always fully pay attention to them when something on the system has broken. And we started to build these resync systems here to try and recover from these states in a way that we can do on demand and just copy data between databases rather than understanding the business purpose that this event has had across the system. So what is an event-driven system? An event-driven architecture uses events to trigger and communicate between decoupled services and is common in modern applications built with microservices. An event is a change in state or an update, like a car being listed on a marketplace. So I think this is a quote from some information of event-driven architectures on AWS. But really here, what it's trying to get across is that the event or the asynchronous message that gets published is there to represent a factual change of the platform, something like a car being sold, rather than a database column changing from is sold from false to true. I guess conceptually it might be the same thing, but when it comes to the implementation, they do semantically mean something slightly different. One is stating a purpose, a fact that has historically happened, rather than the nature of a database just changing. So we've got an event-driven system. Events are facts. They're there to represent something that has happened on the platform. So when I say that, it's usually something that's happened in the past. Someone has sold a car. A dealer has bought a car. A user has placed a bid to sell a car. A user has uploaded an image of a car. And events allow for low temporal coupling. So we don't need both sides of this system to be up for the system to be functioning correctly. Back on that first image that I had with the profile service, and we've got a search service and a dealer service, and these synchronous requests happening between everything, we need all parts of that system to be up for the whole system to be able to perform. But if we have this asynchronous decoupling there, each part of the system will eventually catch up. If some part of the system isn't working because it's down at that moment in time, it doesn't matter. It'll still perform well based on the information that it's got at that time. And events can have many consumers. That's the only emoji I've got for to fan out. So events, we want the ability to fan out. So when a car is sold, we can tell multiple systems around the platform that this has happened. It's that fan out with multiple consumers that you see some of the really powerful benefits from these event-driven systems. So an example of a vehicle sold here, the eagle-eyed amongst us may notice that is not a Porsche 911 on the right, but we've got this vehicle being sold here. So this isn't a representation of a database schema as an example. It's us telling other consumers around the platform that this vehicle has sold. We have some information about the user that's bought it. We have some information about the dealership that has bought it. And we've got some information about the vehicle in the middle there. And all of this information is available in the event. It doesn't require any consumer to essentially call home. When a car is sold, we want the consumer to use everything in the event to build up any information they need to do anything they need to in response to that. Rather than us just having a sale ID in this, a consumer listens to that event and then has to call back to the sales API with that sale ID to get the rest of the information. That would reintroduce that temporal coupling that we need. So we want to try and put as much information to these events as possible within reason to build out this system. And this pattern, I guess, is called event carried state transfer. We're using events to publish and transfer the state of our application between different systems. So I spoke a little bit there about how we had some events. We weren't strictly event driven and what event driven might mean. How did we get there, or what are we doing to become event driven? So some of this, I'm going to look at a little bit, some of the people and process changes that we've made. Becoming event-driven isn't just a technology change that we've made internally. We've had to change some of the way that we think about the business, the products that we sell, and how we visualize these to the customers. So I'll look at how we've run some event storming workshops, how we've identified domains and boundaries. Domain-driven design is a nice component that event-driven architectures help show or help flourish, and some of the changes that we've made. So event storming, has anyone done any event storming themselves before, either in their teams or facilitated any sessions? No hands? Cool. So event storming, a rapid group modeling approach to domain-driven design. So we got all of our a lot of our product leaders and engineering leaders together and started sticking loads and loads and loads of Post-its on the wall. There we go. Post-its going on walls. That's not even all of the whiteboards with Post-its that we had. There was a lot going on here. And the key part of this is for us to understand all of the entities that flow within the motorway process. So we've got cars, we've got profiles, we've got valuations, dealerships, bids on the part of the auction platform. Understand all of these key components and the state changes and processes that happen between them. So that vehicle transitioning, we've got a vehicle entity, it transitions to for sale, to sold, understanding those changes that happen across the system and every part of the system through it. So we started off really, really high level. And then over time, we started to go from that big picture view down to the processes that happen between all of these systems into the specific design nature that all of our engineering teams do. So it's that future end state that we want. And from that, we started to understand a bit about our domains and boundaries. So we wanted to make sure that we had clear outcomes from that event storming session to understand where these business processes happen and the boundaries that happen between them. And the end goal of that was that we wanted to have no synchronous communication between these boundaries. So we shouldn't need to have our dealer system our platform should be able to absorb failure in other systems. So if the dealer system went down, the ability for a user to still profile and sell their car should still work. Likewise, if our transport system went down for any reason, we should be able to still sell cars and profile new vehicles on the system. We don't need these synchronous communication pathways to be up all the time for the key flows that we've got to work. Fail gracefully. Everything fails all the time, and we wanted to really embrace that. And we wanted to start thinking a bit more asynchronously. So this was some of the product thinking that we changed slightly to try and embrace this. So Werner Vogels, the Amazon CTO, said at reInvent in 2002 that the world is asynchronous. Probably not the first person to say it or certainly think it, but everything around us is an asynchronous process. We can order a coffee, and whilst that's asynchronously getting made, we can do something else. I'm sure there are a few software engineers in the room who may want to compile some code, and then whilst the code is compiling, we may sit and twiddle our thumbs, or we may be able to do something else asynchronously whilst that code is finishing compiling. And all of these processes are asynchronous in nature. Everything around us is asynchronous. We want to make sure that our clients, so our front ends or our third-party consumers, don't expect immediate response. So rather than sending some request to an API that says, get me a vehicle valuation, rather than you waiting 2 or 3 seconds to get the valuation and response, we've got a lot of things that happen in the middle. We want to make sure that we can maybe return to you a a valuation ID, and then you can start polling for that valuation ID, and you might get it back in the future. Or we can open up a WebSocket so we can push that valuation to you an amount of time later. In reality, these asynchronous processes do only take hundreds of milliseconds, sometimes a couple of seconds, but we want to build with that failure state in mind in case something does go wrong. There's networks all over the place here, and networks are full of latency that you can't control. In this, event-driven systems start to allow for easier plug-in and modular systems. So that fan-out nature, we can have different parts of the product do different things at different times, asynchronously in response to things happening. And I'll take a look at one of these systems that we built, completely isolated, that works fully in response to some events on the platform. So to become event-driven, we started with this event storming session. We got those business experts in, business experts from across the company, product leaders from across the company, and engineering leaders from across the company together to understand exactly what our product is doing. I'm sure everyone did know to some extent what everything is doing, but we never really mapped it out in such a clear way across so many Post-it notes. We took that, identified our domain boundaries, and wanted to make sure how we would build and architect our systems to be safe within these domain boundaries. And we started thinking asynchronously. Plan for asynchronous communication and build for asynchronous communication. AWS, the AWS user group, can't not mention them. So we chose to build a lot of this system using some of AWS's serverless technologies. And a key part of that was to reduce the maintenance overhead that we've got. So I mentioned at the start, we've been using RabbitMQ for a while. And RabbitMQ is a really, really great broker, message broker, router. It works really well, but it requires some maintenance. You've got to run it in a VPC. It's not a maintenance overhead, but it's a consideration. Likewise, patching, updating, running. It's running 24/7 too. We're a UK business and we sell cars primarily during UK operating business hours. So it means that in the evenings, we're paying for all of this RabbitMQ that we're by and large not using. So we wanted something that would fit our business model and fit our cost optimization and desires to pay per use as much as possible. So we decided to lean on the cloud. It's not just a fancy data center. I think if you treat the cloud like a data center, it'll get really, really expensive. Treat AWS like AWS, and you can get some really, really good cost efficiencies from it. Vendor lock-in, maybe controversial. I think it's a feature, it's not a bug. If you take the very, very best that they offer, you'll get the very, very best that they offer. If you try and treat it completely agnostically, you're not going to get the best things that they offer. I mentioned pay-per-use rather than always on. We want to make sure that we are paying for when we sell cars, process our vehicles and profiling. We don't want to be paying for compute at 2 o'clock in the morning when in reality we have very, very little traffic on the system. And async native services. So some of the really interesting patterns that you've got with AWS are DynamoDB. So DynamoDB is their NoSQL database. When you write something to Dynamo, you get a change stream off the back of it. It tells you what was in the table before and what the update looks like afterwards. It becomes really, really powerful because you can start to then asynchronously take that data, transform it into a business event or a domain event or a fact and publish it. So you don't have to publish your database schemas. You can transform it and send it on to everyone else. We've got this fan out again, this fan emoji, it's maybe the best one. So we used EventBridge. I'll speak a little bit more about EventBridge, but when we push data into EventBridge, we can then fan it out to multiple consumers across the platform. So if I take that vehicle sold event as an example, we may want to send an email to a customer to let them know their car's been sold, to a dealer to let them know that they've won an auction, to an AI or an ML processing system to try and understand a bit about why we've sold that car. And we can do that with this fan out pattern. We don't have to have everything synchronously available all the time. We don't have to scrape databases on a schedule. Everything just gets told about what's happened when it's happened. And then finally, we've got RDS in a lot of places. Again, I mentioned at the start that we use Postgres. We will continue to use Postgres. I'm sure it's a powerful database technology, but it does have some problems with things like two-phase commits. So if we write some data to a database and then the event publish fails for any reason, network fail all the time, in reality, it's a small likelihood of it happening, but when it does, it's bad. Write data to a database, the event publish fails. Our system thinks that we may have sold this car, but we haven't told anyone else that it's been sold. And we need to be able to recover from those situations. So to get around that two-phase commit problem, we would write our database into a database, and in the same SQL transaction, write some data to a different table, to an outbox table, and be processing that asynchronously again. So we would write all of this data in. That great, we've done that job, it's finished, and then asynchronously something will come along, pick up the data that has to get published, and then publish it out. So it breaks away from those two-phase commit problems that we could have. And we would always communicating with events. So we want to make sure that we're publishing facts, publishing changes of state of our system and application to everything else across the application, and thinking about that event storming process again. We want to publish our business processes, a car being sold. We don't want to publish the fact that database column is changed from true to false. It may sound similar, but we want to be very, very conscious that we're publishing these business domain facts and business processes on our platform. Bringing the business along, it's not always really easy to implement changes like this. So we want to sell the positive nature of it rather than sell a migration. I don't think everyone likes migrating everything all the time. Quite often there's no business value to a migration. So you want to sell the benefit that we've got. So you'd find that over time, we started to get to this reliability tipping point. We had a huge amount of synchronous calls that were happening across the platform. And if one part of the system over here goes down, it has this cascading effect that something over here starts to break. So we want to make sure that we're avoiding that at all costs. And the asynchronous processing and event-driven architecture has really helped us with that. So that's the reliability. The cost's a big bit too. I mentioned we want to pay per use. Everything that we do, we want to be able to attribute an individual cost line item to it. And by doing this, it allows us to empower this fan-out process again. We can start to build new business verticals completely isolated and decoupled from the rest of the system. If something goes wrong, or if our new system doesn't work, that's fine. We can just delete it, and we don't have any hangover or legacy anywhere else. There is no code that's aware that all of these new things exist. We want to start small with minimum viable migrations. We don't want to move everything over to this all at once. It's a multi-year big bang project. Again, multi-year big bang migrations, probably not great and very hard to sell to people. So you want to learn from each small bit that we're moving at a time and improve and iterate on it all the time. I think every change that we've made along this journey, we haven't done the next one exactly the same way because we've always been learning and feeding back into the rest of the process to improve it. And then finally, we want to build in safe and decoupled ways. So take that extra bit of data, add new data at a time, remove that temporal coupling, making sure that we are breaking things out in sensible places and extracting business domains and services bit at a time. And it's really important that we champion the success of something. So we did have an example, this is quite a few months now, of a third party that went down for an amount of time. And before we made some of these changes, if that happened, then most of the platform wouldn't have been able to operate. It was a critical dependency in the middle, critical in the sense that it was part of our synchronous path, not critical in the sense that we needed them to be up all the time. So we pulled them out, extracted it, and made it asynchronous. And when they had a problem, it wasn't visible on our site. We queued up all of these changes and then just pushed them through the platform when they came back up. So we were able to really well clearly attribute real business and financial cost and benefit to us extracting this out and making it asynchronous. So a little bit about the differences between events and event-driven. I want to get a little bit more into some of the detail, some weeds on this, and talk about some of the changes and what's really empowered us from a developer experience and reliability point of this. So where we're going, we don't need bugs. We definitely need schemas. Schemas in our events are really important. So I'm going to mention how we built a new product called Instant Match, how we've extracted some of that data out, how we've architected our event bridge systems on AWS. We've got a multi-account, multi-bus pattern, so hub and spoke implementation of it. Why schemas have been so important for us. What we've done to make sure that we are really aware of the events that are happening across our platform, and what we're doing to document all of these events. I think documenting synchronous APIs is a really well and common thing. And people use Swagger, Docs, things like that all the time. I want to show what we're doing with our events to be able to we can document these. So back to the start, this is kind of similar to what we had. We've got our seller system, a dealer system, RabbitMQ in the middle. And then we've got the outbox worker. So I mentioned we don't want these two-phase commits. So this is us building our first building block to our first event-driven part of the system. So our dealer system at the top there would write all its data into its database along with its event into this outbox. We've got our worker that comes along and publishes all of these events onto our bus. So that's the asynchronous part starting to happen. Then we've got our fan again. So we can fan this out to as many different consumers as we need. I've got one highlighted here, and this is the instant match system. So this is a system that we built to try and help match dealers who've just bought cars to potential buyers of those vehicles. And instant match, we weren't sure how well it was going to do. We wanted to build it, try and get some feedback and iterate really, really quickly on it. And we didn't want to have to make invasive changes on the rest of the platform to be able to prove the success or failure of this product. So we've done this in a completely asynchronous way. Actually, in reality, everything on the right-hand side of the fan, we could just, if it didn't work for us, we could just delete, and we're not left with any technical debt in any part of the system. Everything on the left doesn't know anything at all about anything on the right. There's no API calls to endpoints we'd have to remove. If we just deleted it, everything would still just work fine. And because it's all pay-per-use, we knew how much it would cost us per user using it in advance. So sometimes it is kind of hard to model how much serverless systems may cost, but with this, we were able to get a reasonable understanding of the exact cost it would be. And I think it was in like the pennies. Maybe it cost us $1 a month to run this the way that it was set up. So we're able to start to build out here, and we're starting to introduce the first events on Motorway. We really, really didn't want to risk that core. We're thinking back again to the start. We've got our domains on the left and that event storming process on the right of how we got there. And we didn't want any of this synchronous communication going east-west, left to right. Synchronous north-south is fine, but everything must go across this event bus in the middle, that event bridge that we used. So how did we start to architect this across the platform? So we've got multiple environments within AWS. So these are separated by org units or organizational units within AWS's account structure. The reason that we did that, it gives us a really, really clear separation of concerns. We know that we've got strong guarantees from AWS that things inside this org unit will not be able to talk to anything in this org unit. Unless we explicitly build it, there is no way we can get network traffic crossing these boundaries. There is no way we can accidentally read databases from the staging one instead of the production one. We cannot do it by splitting these accounts out. And again, we wanted to go one step further than that. Rather than just having an account for dev, stage, and prod, we wanted to have accounts for our business domains and boundaries within there too. Again, that would further help us enforce that east-west, north-south traffic divide, and we can build in preventative measures to stop synchronous traffic going between our business domains and forcing everything onto this asynchronous bus that we've got. So big box on the outside is our AWS production org unit, so our production environment. And then within it, we've got 3 AWS accounts here. We've got a dealer account, we've got our backbone or our hub event bridge account, and we've got our transport account on the bottom right. So there is no way that this dealer service can talk to this transport service. Everything is synchronously. There's no way they can talk to each other synchronously. Everything must go asynchronously through this backbone account up at the top. And we've got organizational policies in place to help guarantee that. So anytime something changes within the state of this dealer service, it can publish this event onto our bus at the top. I've got the example there of a vehicle purchased event. And then from that vehicle purchased event, we can route all of those events into our transport system. So when a vehicle is sold, we need to know whether or not we have to arrange collection and delivery for it. And we've now got this asynchronous process in place that allow us to do that. If the dealer system for any service wasn't up at any moment in time, if the transport service wasn't up at any moment in time, the dealer system doesn't care. It doesn't need the transport system to be there. It's not making requests to it. It's not calling an endpoint, order collection. It's publishing a vehicle purchased event. It doesn't care what its consumers do with that information. And if the transport service was down, when it comes back up, it doesn't matter. All of that information is queued up and we can start to asynchronously process it. Again, in reality, we're talking hundreds of milliseconds here. So the consumer's feedback loop is still super, super small, like seconds at most, but it does mean that in failure states, it allows us to easily recover, and both systems can still operate independently of each other. And then up at the top, I've got the Motorway registry. I don't know if people can see that icon super clearly, but has anyone seen that icon at the top right before? The Lego brick icon, nearly, okay, kind of, I guess, with where we're going. So that's actually the AWS resource logo for the schema registry. Really, really cool, a really, really cool part of EventBridge, schemas. Schemas, so important for everything that we do. I mentioned, again, that documenting synchronous HTTP APIs, I think something that's very, very common. Almost every web framework supports things like Swagger and OpenAPI specs. Schemas for asynchronous systems, I would say not quite as mature yet, but we're wanting to really make sure that we're driving everything we do driven by schemas. So as Steve says on stage, schemas, we're making sure that we're doing it everywhere. So I don't know if people are familiar with TypeScript, but I've got a TypeScript file here with a couple of TypeScript interfaces. This, whilst this is a TypeScript representation of an event, I'm going to say it's not a schema for the event. It's just some TypeScript code. This is fine, and it's fine if you can read and write TypeScript. It's fine if your system is in TypeScript, but if you have a Python system and you paste that into your code, it's not going to work. You're going to have to translate it somehow. So this is not a schema. This is a schema. It's a bit smaller, but this is a JSON schema document. It's actually a JSON schema representation of that same TypeScript set of interfaces, but this is the way that we're able to share these schemas across all of our different systems. You can't read it. What it says is not quite so important, but the important bit is that green tick, that it is a schema. It's not a code sample that we share with people. It's a schema that we share with people. And we communicate using these schemas as our interfaces between our systems. So again, it means that each system doesn't have to be written in that same language. It's removing that language coupling between things. And we're able to visualize and document these schemas in a way that we need to. So the second important bit, other than schemas, we want to make sure that we're knowing what we're publishing onto this EventBridge. So EventBridge has got a nice feature on it called a resource policy, and allows us to apply an AWS IAM policy to the resource itself. And by doing this, we're able to guarantee that only a certain set of information is able to be published to this. We don't want every system publishing anything onto the bus. We want to go through a review process, much in the same way that people might want to review API specifications before we release them. We want to do the same thing with our APIs. And by enforcing IAM policy validation on our EventBridge, we're able to understand exactly what is going on here. So I don't know if you can see it, but in the resource policy, in my condition block, I'm saying that I allow any string that's equal to the detail type, vehicle sold, dealer created. There's a huge list of these, of the events that we allow to be published across our EventBridge. And as part of the review process for this, we want to make sure that they've actually got a schema attached to it. So we can enforce the type of information that you're sending, and we can then guarantee that you've got some detailed documentation for what that event is. Which leads me on to the next bit, that documentation of your events is really, really important. And we can do that with this enforcement and process that we've got in place. So the schemas are key, schemas. Having the schemas lets us document the schema. It starts to let us build out visualizations of it and understanding what we've got across the platform. We want to make sure that we know our producers, who's sending the events. We can do that because we have an IAM policy in place that permits only certain actions to happen on the bus. And then we want to know our consumers. And EventBridge has rules. So in order for you to consume an event from EventBridge, you have to have a rule created on it that will route your event from the bus to your system application. And at the end of this, we're able to document and visualize all of the events going across the platform. So This is a tool called Event Catalog. It's an open source tool. It's really, really cool. And it allows you to visualize your schemas. It's something that is really, really important because your schemas are your documentation. The producers of your events are the sources for this information, and your consumers are a key part of any event-driven system. It's really, really important. I mentioned before that our systems don't know what happens once an event has been published, and that is true. Software shouldn't know who the consumers of the events are, but the humans should. We're all writing it, and we need to know who our consumers are. We need to communicate within the business, and sometimes we have to change the events. So this system allows us to visualize the documentation. We've got our event on the left. This one here is payment initiated. In our world, it's dealer created, vehicle sold, things like that. And we can click into that, and we can see a human readable version of that schema, because they're schemas and they're not source code, and we can read it. We've got our events in the middle. In this case, it's a consumer. And then we've got, the service in the middle is the consumer, and then our events again on the right. Documented, visualized, and easy for us to see. It means that anyone across the business can come in and view our event catalog, quickly search for something like driver's license, and we now see all the systems that publish information about driver's licenses, or we can see any system that publishes information about dealers or car dealerships or vehicle images or car mileage and valuations, and do anything that they want to with it. And because this all gets built automatically, it's kept up to date and continuous all the time. We have enforcement policies to make sure that we know what our events are, that require us to have schemas that feed into this system, so it continuously gets generated and kept up to date. Final thing I want to quickly touch on, don't break prod. Who has ever broken production by mistake? A couple of hands. Who's ever done it on purpose? Couple of hands again. Cool. Okay. So we want to make sure that we don't break prod on purpose or by mistake. So we're building our again using schemas to try and drive this. That every time a schema is created, we're sticking that into an S3 bucket. It eventually makes its way into our registry, but any schema that gets added to the bucket, we've got an event, because we're event driven all the way through, that's triggering a Lambda function. And our Lambda function can then take the schema that you've just uploaded and compare that to the previous one. And if there's a breaking change between them, then it just won't add it to the schema registry. So your event won't be documented. We can't publish it onto the bus because no one's going to be able to review your policy change. So we can then start to programmatically enforce that we cannot have breaking schemas and breaking change events getting pushed into production by mistake or on purpose, hopefully not. But we can make sure that we never even get that far. Once it's in production, it's hard to pull it back in. So you want to stop it before it even gets there. So I'm done. I think on time-ish, hopefully. Cool. I've got aircon or a fan at least back here. I don't know how hot it's getting there, but yeah, I'm getting a bit toasty. Some of the key takeaways. Schemas. Steve Ballmer's developer meme is still relevant a long time ago. I don't know when he said that, but it's still relevant today with schemas. Really, really important for what we do. We want to make sure that we use them to document things, to share bits of information between systems. JSON schema is a standard. So in almost any language we've got, we can validate events before we send them with JSON schema. All of our consumers can always validate your inputs, can validate every input that it conforms to this well-known schema, and we use it to document things. Documentation visualization helps us move fast. We have a list of all the events that we publish with all of the documentation for all of those events to understand how they all work. And because none of our systems, our people do, but because none of our systems know of any of the consumers, we can just start to add a new one. If someone wants to build a new thing over here, that's fine. Here's the events. You can listen to them all if you want. We can replay them all off of the event bridge, and you can build up all the information and data you need and essentially use it however you need to use it. And then a key part of all of this, one of the, the well-architected framework pillars in AWS is cost. It's not the only one. You shouldn't architect only for cost, but it is a really, really important one. We want to make sure that we're building things in a scalable, safe, and cost-efficient way. EventBridge, you pay per use, so it's no underlying cost. AWS accounts are more or less free, and the glue in between them are more or less free. So we're able to build this in a really, really nice, distributed and isolated way where any part of this system blast radius is not big enough to take down any other part of the system. And we can do all of this in a really cost-controlled way. I think that is me. Thank you. Do questions now, later?
Yeah, so we're going to take just 3 questions. So we've got time for Reke's talk, but both Ryan and Reke will be here after their talks. So if there's more than 3 questions, feel free to ask them in the bar afterwards. If you're feeling a little bit shy, we have got some swag for questions here.
We do believe in bribery.
Ask a question, you'll get an answer and some swag. So John's got the roving mic. I'll give this back to Ryan.
One there, one there, one over there, one over there. Fight amongst yourselves. We'll stand
Thanks. Hi, it's Steve.
Bizarre question yet?
Absolutely bizarre. Okay, thank you. Just really interested. The way that I get it, schema. So you're coding the system. You've got an abstracted model of that system through schemas. You can visualize those, chaining them together. The really critical thing that I saw that I didn't quite understand was, if you modify a schema, you have this funky lambda that goes, is this broken? Does this break something? I'm kind of curious, what kind of things are you checking for that identifies what's broken and the potential blast radius?
It's a really good question. And the hidden slide that I didn't show was the title slide that says, what's next? So that we've got a plan for it. So it's mostly written, it's just not running yet. Coming soon, if you work for Motorway and watching this at home, really soon. So there are a few libraries. The one that we're looking at in particular is in JavaScript, TypeScript, and it can diff the schema of a JSON schema object, and it's just got a rule engine inside it that knows if something's broken. I think like the obvious ones are, if a property's been removed, almost always a breaking change, can't remove properties. We want to be building all of our systems to be like tolerant readers, so we can add new things as an exception. We can add new things, and everything should be able to consume that in a safe way. It just ignores the bits that it doesn't need. The slight exception with that are, there's probably a couple, but the big one that stands out are enums. So if we're publishing an object that's an enum of something, we probably consider that adding an item into that enum would be a breaking change, because it almost fundamentally breaks the behavior of what it is that you've got. So we're going to try and avoid those as much as possible. We'd use array of strings rather than an enum, a subtle difference. I guess compile time languages will throw exceptions, or a lot of them will throw an exception if you're trying to deserialize something into a compiled enum. If it's an array of strings, it probably wouldn't matter, and you'd only then pluck out the if string is in my array, good to go.
There's a real rabbit hole there, but thanks for showing some great examples. Thank you.
Question 2 from either no beard or an enormous beard. Question, only one hand. That makes it easy.
You might not want to give me the swag because you might consider it the same question, but it is around schemas. And I guess you might say things become optional, so you have no breaking changes. But over time, don't you end up with enormous schemas with everything that's optional? So how, like on a synchronous API, if you're using JavaScript to validate an API for RESTful calls, you would perhaps version the API, start with v1. I mean, down there's a whole rabbit hole of nastiness with version control on endpoints on synchronous APIs, but how do you manage change and the complexity of change in this event-driven world and schema when there are breaking changes? You can make everything optional, but there might be.
That is a full-on, like, next year Ryan's problem, I think, rather than this week Ryan's problem. So It's another like easy out on the answer. So we have gone through this a little bit. So we do already version our HTTP synchronous endpoints, and we'd want to do something similar with our event ones, because we've kind of got like almost a clean slate with a lot of this. We're wanting to not have thin or fat events, but put what we think we want in the future in them today, so that we don't have to keep adding stuff optionally in the future. We will be adding things optionally for sure. And there is, I don't think I've got anyway a right or wrong answer on when enough optionality is too much. But because we can visualize it, maybe this magic Lambda function will start to think, if you've got 100 optional fields here, then raise an alarm bell and figure out what we want to do. And I think by the time that you do have that many optional fields, the intent or the business intent of what that event was there to do has probably in some way changed so much that it probably does warrant a new event. It might be a V2 of an event, but if the functionality of the business process and intent has changed so much, it might just be a new business process that you've invented and you're trying to shoehorn it into something you've already got, which is the two options that I think we're probably going to come across. The adding optional stuff was the default to begin with for a while, and then at one point, we will just bump them. Interesting thing though with EventBridge and the rules, because we've got a clearly defined list of all of the consumers, we know exactly what teams, because we're people and we need to know who our consumers are as people, the services don't, we know exactly what teams we have to go and talk to discuss versioning an event or bumping it or migrating people off. Whereas with HTTP things, sometimes you've just got a bunch of people who are calling you. You might have an API key per client, you might not know who's calling you. So we think that this system will let us have those conversations in an easier way when they happen. But breaking changes are painful and versioning stuff is painful. You've got to keep the old one around for ages. We can see who's using the old one, which is a bit easier, but yeah, I don't think I've got a magic bullet answer.
Great, thanks. Good luck.
I can let you know next year.
Don't want to be future Ryan. One more question. One down the front there. Anybody else? One over there. Can you arm wrestle for it, or? You sure?
I was just wondering, how difficult was the transition from changing gears, going into event-driven on a personal level, on a people level? Did it take a lot of retraining and sort of poking people, oh, you shouldn't be doing it this way, you should be doing it this way, or did everyone pick it up easily?
So the last 5, 6, maybe 10 slides of this were new for tonight, and the first half of it is kind of a repeat from the EDA day.
Right.
The 10 slides tonight, I actually hidden 10 slides that I gave before that touch exactly on that subject, on like the people and the process changes that you've got to go through. And I think one of the slides is titled, it's all about the people, and it is. The paradigm shift is if you've not done it before, it's a change in how you think about building systems and software. It's fine. So we picked some teams, we upskilled some teams first, training AWS partners helped, AWS account teams helped, and then these teams then started to try and spread that tribal knowledge internally. It's part of the reason that we didn't go for some big bang, do everything all at once approach. We wanted to make sure that we did do something small first, learn from it, share that knowledge, come back, do it again, learn from it, and so on and so on and so on. And we haven't finished, right? Like, we're still going through this, and it isn't we've been doing it for 6 months, everyone knows it now, we're done. It's a long-term thing. And a lot of the stuff that we've got works, and we don't have to change it. We want to find the bits that are causing us pain and start to move those out as we go.
All right, thank you.
Hello, I'm going to have to speed up. So, am I good? Perfect. Better now? Perfect. So take, for example, your CEO of a thriving company, an e-commerce company, for example, and your business essentially just allows you to thrive the aim of your business is to thrive in the AWS environment, making sure that you're building stuff that is secure and reliable for operations. And then one day you get a phone call telling you there's a breach. So attackers or a hacker, let's say, has been able to compromise your account and steal several customer informations that are sensitive in nature. So, and it's also impacted your companies running at the same time. So in that heart-drenching moment, you're thinking, where do I go? This is a damage to my brand. This is going to cause regulatory fines as well. So loss of money and also the loss of customer trust. So in that moment, it's not something an executive would want to happen. And then you're thinking, and you're also seeing the importance of reducing your attack surface in the first place to kind of prevent that from happening. So essentially, this session is going to kind of run you through some of the basics that it would take to mitigate, not mitigate per se, but it would give you some of the strategies that you can take that would allow you to reduce your attack surface. So it would essentially allow you make your AWS environment a sort of fortress so that when an attack comes, you already are relatively prepared. You've put measures in place to make sure that it doesn't attack you or it doesn't hurt your business too much. So today we would be going through a couple of agendas, but it's important to note that given the nature of the topic, it's not going to be at a level 400 just because it will take a lot of time. So I will be going through most of the things that are potentially forgotten by most people when they're becoming new to cloud or even cloud security. So we'll be discussing how you can, the importance of having an attack of reducing your attack surface and what an attack surface is. We'll also be looking at, of course, the principle of least privilege and how it would help you mitigate some of the potential issues you would arise. And we're also going to see an issue that arises from not taking enough precaution for least privilege. Then we'll touch upon some very basics of network security. So we're going to see what's different with AWS as opposed to a normal on-prem. Then obviously we're going to touch upon monitoring and automation and some AWS services that would help you. Then finally, I put a case study for us to kind of work through. And again, it's important to note that this case study is publicly accessible. It's not confidential, it's public knowledge. And yeah, so the first thing that we kind of need to understand when it comes to reducing the attack surface is knowing what an attack surface is. So it's essentially just having multiple points that is available to potentially cause a vulnerability in your system. So it's not just, for example, having a security group that is too permissive. It's a compilation of every single flaw that you could have with your system. And when we look at why you should minimize your attack surface, we can see that one, of course, it would help you with protecting from sensitive data stored in your AWS environment. For example, when you have this in place, one, you're helping with your compliance, making sure that whatever data you have there isn't compromised that can potentially lead to GDPR. You also want to have some sort of automation and testing so that when it comes to your CI/CD pipeline, if you have a potential security issue, the security controls that are automated would essentially allow you to mitigate it or attend to it as soon as you see it. For better resource management, and this is more to do with the operational overhead, because when you've done that in place, you're actively making sure that no part of your business is potentially free from attack or open to attack, sorry. And of course, the complying with AWS best practices and industry practices, because of course, like I mentioned before, we have the GDPR, we have the PCI DSS, and the HIPAA, of course, depending on the kind of compliance that you're facing. So you need to make sure that it's also following AWS best practices. And then when we look, of course, into the principle of least privilege, it's something that we find that as much as we say, give only the least privilege required to do anything, a lot of people just still don't do that. A lot of people would just use what's convenient, it's working, and then use excuses of it's a test environment, it's a dev environment, it doesn't really matter. But having that mindset in place would allow you, regardless of what kind of account, to ensure that you're always following it, so it becomes kind of second nature to you. Then here we see some of the benefits. So first of all, what is the principle of least privilege? It's essentially making sure that any user group or processes have the minimum permissions required to do a required task. And some of the benefits that you'd have from that is, of course, limiting potential damage. So if a user or a role or a group is compromised, the attack surface would probably be very little, depending, of course, on the actual role, for example, that is breached. And then we can also see the reduced risk of human error. This has more to do with accidental deletion. So, for example, you have an S3 bucket, and then in the S3 bucket, it has sensitive data, so it has PII in it, and you don't want the data to be deleted because it's being safe for GDPR requirements, and a confused developer who's basically has way too much permission comes along, and then they decide, oh, I don't think this should be here, let me delete it. And then you have issues arising for, say, a customer says they want to be able to view the data and it's no longer available. And of course, compliance. And you would actually find that most of the benefits when it comes to strategies is going to be compliance. And this is just because compliance plays a very big part, of course, in security. And here we're going to just see a couple of AWS tools that would help you with your, I guess, journey with least privilege. Of course, we have IAM, Identity and Access Management. And if you're using AWS, you probably already know the service. And of course, we're going to touch upon resource-based policies, which Ryan also showed in his slides, and AWS organizations as well. Now, when it comes to IAM, we can see that IAM allows you to have that least privilege because you can have some sort of granular access, ensuring that users and groups, or user groups and roles, have only the required permissions that they need, and just narrowing it down to what is required. And when it comes to resource-based policies, those are obviously looking more at the services as opposed to the overall. So, for example, you can have an EC2 instance that has a resource policy attached to it instead of obviously putting a bucket policy, which we would actually see an example of in the next couple of slides. Then we also have AWS Organization. Now, AWS Organization is mostly used by customers that have several AWS accounts, as Ryan mentioned. And what exactly happens with respect to least privilege is that AWS Organization has a type of control policy in place called the SCPs, the SCPs, basically. And what it does, it allows you to have a granular amount of permissions that can be spread across your entire account. So it can be at the organizational level and the account level as well. So the OUs and the account levels. Then now we're gonna see some interesting bits when it comes to the confused deputy problem. In AWS, so basically, the cross-deputy problem happens when you've not accurately followed the principle of least privilege, because you've not necessarily given too much problems, but it's an issue that arises from not accurately putting it in place. So you're going to ask, what is the confused deputy problem? So first of all, the confused deputy problem is essentially when an entity has a specific permission attached to them, and then they kind of coerce another entity who has an even more permission to do a task on their behalf. Now in AWS, we have another type. So we have the cross-account deputy problem, and then we also the cross-account confused deputy problem and the cross-service deputy problem. But for today, I'm going to focus on the cross-service confused deputy problem, just because it kind of matches with the issues that we're going to see. So the confused deputy problem is when you have one AWS service, and it could be called the calling service. And then the calling service is essentially trying to make another AWS service called the called service to do a permission on their behalf, which kind of similar to the confused deputy problem. And then what then happens is, in order for you to mitigate these issues from happening, you have to take advantage of the conditions that are available within IAM. And one, you could use the AWS source ARN, which basically allows you to narrow down on the permissions to say, you need to have this particular ARN, which is of course the Amazon resource name, that if they should be able to run this permission, provided it is, for example, this service. And then we also have the source account, the AWS source account, which means you should only be allowed to run this or do an action if you are from this particular account with the AWS account. So next we're going to see an example to kind of put it into place. So take, for example, you have an S3 bucket that has sensitive data. And you also have an EC2 instance, but you want that EC2 instance to be able to access the data in the S3 bucket. So the first logical thing you'd want to do, which is safe and secure, is to not put the EC2 credentials in the S3's bucket policy. So you probably say, actually, let me just provide an IAM role. And then the IAM role, I'll give it permission in the instance profile for the EC2. But there's an issue here. Does anyone potentially want to pop what you think it would be? Sorry? Yeah, exactly. So if an attacker has access to that EC2 instance, they could potentially be able to misuse the permissions attached for the role. And of course, a potential mitigation, which is probably a clue from the previous slide, is to use the policy that would check the EC2 instance before allowing them to perform the action in the permission. So now we're going to touch upon network security. Now, network security is a very, very broad aspect. And obviously, I can't cover every single thing, but I would be looking more on some of the basic parts that AWS is more AWS native. So of course, we talk about why is it important? Why should I care about my network? Well, in AWS, when it comes to network security, it's slightly different from on-premises because we have our native services or native features, I would say, that are also included in it. Network security essentially just allows you have your AWS environment more secure, because what happens is you need to ensure that, for example, the firewalls that you have are blocking access, because when it comes to people, the importance of network security, we're seeing, okay, so you want to have direct flow of information in and out of your system. So you want to make sure that whatever is leaving or whatever is coming in is safe and it's not going to compromise your accounts. So we then look at security groups and NACLs. Now, NACLs are network access control lists, and they're obviously native as well to AWS. You probably see this if you play around with VPCs. It's important to note here, though, that when it comes to security groups and NACLs, we usually recommend obviously security groups because, again, they're at the instance level and they're stateful, meaning that the outbound and inbound traffic, whatever you put, you don't have to define it again, as opposed to the network access control list. The other thing to mention here is that when it comes to what you want to use, you would usually use the security groups as opposed to NACLs, because NACLs, again, if you mess it up, it's going to mess up your entire VPC. So they should only be used as a secondary security measure. Okay, now we're going to touch upon continuous auditing and monitoring. So in AWS, we have obviously AWS CloudTrail, which basically logs your API calls that you make. So every action that's running your AWS account is being logged in CloudTrail. So we can see here that whatever is logged in the audit logs, they all get stored in your S3 bucket, and they can also be put, you can probably see at the top. So if you want to retain your S3 logs because of compliance, for example, you would be able to transfer it to Glacier at a lower cost, because again, that's probably some things that people are looking to when trying to build things in the AWS cloud. So when they're stored in S3, you can then run some sort of architecture on it. You can decide to enable alerts so that if there's a breach, or not a breach, sorry, if you're trying to get a cumulative, like when this action happens, somebody should be notified, you can then use the alerts, and you can also analyze them more using OpenSearch or even Athena. And then if you want to use a third party, there's obviously Splunk that's also available. And then you can also integrate this in your CI/CD pipeline so that when any particular actions happened and maybe someone's not notified, it can allow you to, or if there's a misconfiguration actually in your CI/CD pipeline. Then yes, we also see another important tool here, which is config rule, well, AWS config. And what it does is that it essentially just, it logs all the configuration changes that happens in your account. So in the example we've seen that CloudTrail logs are stored, we can incorporate config rules to basically allow you to remediate some of the issues. So you've set up a rule that says users shouldn't log into their AWS account past a certain time. So what happens is, after the CloudTrail log is run, and then you set up the alerts with config rules as well, it would then remediate. So once they've tried to log in, it can basically log them out and tell them, log them out instead of having to call somebody and be like, why are you on the phone? It can do that already for you. So here I've actually put up a screen grab of what a dashboard basically looks like. And in this example, there are a couple of config rules that I've put in place here. So it would tell you which different resources are non-compliant, and then you're able to kind of see what the rules are with a more detailed, like if you click on each of them, you see like more detailed looks on it. Now, we've been able to see some of the basics on why you should you should minimize your attack surface. We've seen some of the principles of least privilege, and also why network security is relevant in all of this. So now we're kind of going to put all that knowledge together with probably what we already know to go through a case study. So I'm going to ask a couple of questions, so feel free to answer. So for this case, we are going to be using the Capital One breach that happened in 2019. A couple of people probably know this attack already. So what happened in the breach? Basically, over 100 million people's data got compromised. And it was as a result of a misconfiguration with AWS WAF. Now, AWS WAF is the web application firewall that we have. And so, first question, what do you think are some of the issues that would have happened from this breach? Like, what would be the impact on the business, capital one? Sorry? Loss of trust. Yeah, basically. Exactly, regulatory. Yeah, you did. Basically, a large bill. So yes, all of you are completely right. You would have regulatory fines. And I think, again, they're a financial institution, so it's going to be hefty. And obviously, yes, the disruption that you'd have in your cloud service. So you won't be able to access, people are going to, again, like loss of trust. I didn't put that there, but everybody knows loss of trust. So now another question. What do you think are the potential lessons learned from this situation? What could they have done differently? Test.
Why we store the customer's data?
Mm-hmm. Yeah.
Why? Because we use the RTB form.
Yeah.
If I store I have my data, let them send it to you. If any transaction leave, I can share it with the transaction. But just beat this transaction. Why you store my data?
Mm-hmm. Those are questions that definitely should be answered. But again, so of course, one, they could have actually had a stronger access control and monitoring in place. So they would have seen that there's an issue with who's accessing information stored. And again, they could have thoroughly validated the configurations. These are things that they were able to just quickly miss, like it should be all right, it should be fixed, it shouldn't be an issue. And of course, data protection and encryption. So if the data that was in the S3 bucket was encrypted, even if it got leaked, it wouldn't have had much of an impact. It would have just been jumbled up numbers. So next, of course, incident response plan. If they had one in place, it would have been very quick for them to bounce back after that. It would have been very quick for them to say, oh, okay, we lost access. We can't do anything, especially with the disruption. The time it will take for them to come back up. If they had that, it wouldn't have been much of an issue. So anyways, that brings me to the end of my session. And I would just like to say that with everything that we've seen today, I hope I've been able to show you some of the very basics that you would need when it comes to ensuring that you're keeping cloud security in mind, and also ways you can reduce your attack surface. And also, there's a QR code. AWS is very data-driven, so we would like you to basically complete this survey. It's literally one question. There's an option to put your name, but don't feel like you need to because it's optional. It would work regardless. So yes, just scan the QR code, give your feedback. It'll be very nice going forward. Thank you.